So it might look like here, I'm giving us an example to do. And you might think, what on earth I'm doing? Because I've only just told you what an identity symbol is and what identities are all about, not necessarily how to solve them. Well, this is a video that's going to be kind of just a discovery into how to solve identities questions. And we'll carry over and do a second example in due course. But at a sort of base level, you can almost think of the triple stack equals like an equal symbol for now, or a double stack equals, and then we'll see where that takes us. So if we have that these two brackets, 2x take away 3 times x take away 7, is identical to some generic quadratic for all a, b, and c. Well, let me rephrase that. A, b, and c are the coefficients. It should necessarily read for all x, also in the reals. So that's something I'll have to fix once I'm reviewing my book. So we'll progress just with a standard equal sign. And we're going to say that this is equal to ax squared plus bx plus c. Now, in expanding these brackets, we get a 2x hitting the x, giving us a 2x squared. 2x by negative 7 gives us negative 14x. Negative 3 times x gives us negative 3x. And then negative 3 by negative 7 is plus 21. It's still equal to this generic quadratic, which if we group all the terms, we get 2x squared to take away 17x plus 21, and we want that to be the same as ax squared plus bx plus c. Now note, if these are the same, then the amount of x squareds on the left have to equal the amount of x squareds on the right. The amount of x's on the left have to be the same as the x's on the right, and the constants have to be the same on either side as well. Okay? So in order for them to be true, this might ring bells with algebraic division, but if the x squareds are the same, then 2x squared is the same as ax squared, so a is 2. If we compare the greens, we get negative 17x equals bx, so b is negative 17. And with the pink, well, we get immediately the c is 21. So what we've done here in these is a method known as comparing coefficients. And in a sense, the amount of x to the n on the left-hand side has to be equal to the amount of x to the n on the right-hand side. So we're taking whatever on the left, the corresponding powers, and ensuring the corresponding powers on both sides of the equation are the same. And that's the method of comparing coefficients, which I will demonstrate in another example.